In this presentation, I'm going to talk about my research topic, which is turbulent BORES-induced scour and pore pressure variation around the vertical structure. I will start with giving a brief introduction about this topic. Then after, I will explain the objectives of my research topic and the novelty involved in this study, and we will see experimental setup and instrumentation that I used to run this experiment, and finally we will go over results and conclusions. Coastlines in many parts of the world experience tsunami or they are still vulnerable to these natural incidents. What is important is that some parts of these coastlines occupied with some important structures like residential buildings or some infrastructures like hospitals and fire stations. What is important is that we need to realize how we can keep these structures serviceable even during a tsunami and after that. In these recent decades, East and Southeast of Asia experienced some severe tsunamis. For instance, the recent one happened in 2018 in Indonesia, and the strongest one happened in 2012 in Japan. As you may know, tsunami can be created due to some underwater sources like earthquake, volcanic eruption, and even landslide, and they can be different due to their heights, their period, and proximity to impacted area. Usually after the incidence of a tsunami, some field investigations occurred in order to collect observations, data, and analyze them. For example, in case of Japan tsunami, the analysis of a field survey showed that almost 50% of a structural failure took place due to a scour or erosion around the structure, which showed the importance of doing further investigation in this field. In most cases, scour is associated with pore pressure variations among soil particles, which can reduce vertical effective shear stress among particles. In my study, we tried to see how different bore depths and also bed slope and bed conditions can impact on hydraulic characteristics and pore pressure variation and scour erosion around this structure. For this purpose, we measure time history of flow velocities and water surface elevation with having different tsunami-like bore depths and two different bed slopes and two different bed conditions, which were wet versus dry. Also, we measured the time history of pore pressure variation around the column at the same time with measuring the scour development around the same column as we had identical hydraulic condition, two bed slope and two bed conditions. Before starting my study, I tried to see what kind of related investigation happened in the past. I realized that in 2019, McGovern and his colleagues, they performed multiple experiments to see how tsunami-like waves can impact on scour development around the building, which was placed in horizontal bed. And these waves were generated using a wave generator. In 2013, Tonkin and her colleagues, they conducted a series of experimental investigation to figure out how solitary waves can change pore pressure variation and scour development around this land, which was placed in inclined bed. In 2012, Key and his colleagues they did multiple experiments in order to figure out how combination of waves and currents are affecting the variation of pore pressure and scalar evolution around the sea range. And finally, in 2008, Nakamura and his colleagues also did experimental investigation to realize how solitary waves and isolated waves are impacting the variation of pore pressure and scalar development around the structure and structure installed in horizontal bed. By analyzing the conducted investigation in the past, I realized that in all cases, tsunami bores simulated as solitary waves, currents, regular waves, or isolated waves. And the analysis of some field investigations showed that these kind of waves cannot experimentally represent a real tsunami waves. However, the analysis of this field investigation showed that dam break method is only method in order to replicate a tsunami waves in experimental scale acceptably. On the other hand, looking at the previously conducted experiment showed that in some cases they just look at the scalar or they just put the column like their structure in horizontal bed. This is where novelty came into my research. We use dam break method in order to simulate tsunami waves in experimental scale, as in terms of the hydraulic characteristics, dam break waves and a real tsunami waves have acceptable agreement with each other. And in second step, we investigate and analyze the effect of different bore depths, two different bed slope and two different bed conditions on time history of scalar evolution and pore pressure variation around the structure. And we studied a whole variation of how a simultaneous variation of pore pressure and scalar can impact on vertical effective shear stress. And also we tried to experiment how we can have liquefaction around the structure. On this slide, you can see the experimental setup and instrumentation that I used to perform these experiments. I did my experiment in hydraulic lab in University of Ottawa, and there is a flow with length of 30 meter, which has almost 22-meter reservoir, and right after that, we installed a swing gate, and after the swing gate, we had an upstream false floor with purpose of calculating bore front velocity and bore surface velocity. At the end of the flow, we had a downstream false floor, which helped us to have a framework for implementation of a sediment section. And right at the center of this section, we place a transparent column, and by putting one camera inside, we have been able to record time history of scalar evolution around the structure. We installed 19 tensiometers on the front side of the structure in order to collect time history of pore pressure variation for this phase, and by rotating 90 degrees of this column, we recorded all these numbers for the side phase. As we had a different bore depths, two different bed slope and two different bed condition, we had different flow velocity and flow depth, which gave us a different fruit number. So based on these different fruit numbers, we categorize our experiments into supercritical flows and subcritical ones. As you see in this slide, once we open the gate, the dam break bore generated, and it traveled and propagated over the sediment section, and by its propagation, a scalar happened and pore pressure changed at the same time. Once we collected all these data and numbers, we started to analyze them. First of all, we started with pore pressure variations. In terms of the effect of initial still water depth, we figure out that as we increase initial still water depth, we had a greater pore pressure values around the structure. Moreover, as we increase bore depth, we had larger pore pressure values around the structure. In terms of the effect of location of tensiometers, the analysis of collected data showed that regardless of bore depth and bed slope, front face of column always showed the greater values of pore pressure compared to the case of side face. Moreover, we realized as we increased bed slope by 5%, the values of pore pressure around the structure doubled. In the second step, we analyze the results of scour development, and in terms of the effect of initial still water depth, we figure out as we increase initial still water depth, it actually mitigates the scour depth around the structure. But when we increase the bore depth, it caused an increase in scour depth around the structure. And when we increase beta slope by 5%, it actually decreased the depth of a scabbard hole around the structure. After analyzing these results, we conclude that the time history of pore pressure variation increased as we increase initial still water depth and bore depth. However, increasing initial still water depth mitigate a scabbard depth around the structure. For all investigated pore depths, we always had larger pore pressure values in front face compared to the case of side face. And also, with 5% increase in bed slope, we had 2 times larger pore pressure values around the structure in inclined bed test compared to horizontal bed test. For identical hydrodynamic conditions, scabbard depths were deeper for horizontal bed compared to inclined bed test, and for all investigated bore depths and bed slope, scabbard depth was significantly deeper in the corners of a structure compared to the case of front and side face of the structure. These are my references, and thank you for your time and your attention.